Question 54, asking about how to count the number of leaf nodes in a tree. So first question is, what is a leaf node? What is considered as a leaf node? So the definition is, if we have an existing node having no left child, no right child, then that node is a leaf node. So taking the tree that we had in last question as an example, this is a tree node 63 because this node has no left or right child. And 19 is also a leaf node because it has no left or right child. Similarly, we can also find 51 as a leaf node, and 37 is another leaf node. So in this tree, we have 4 leaf nodes. If you're asking why 42 is not a leaf node, 42 has a left child, so it's not a leaf node. And 99 is not a leaf node because it has a right child. And 74 is clearly not a leaf node because it has both left and right child. So a leaf node must have no left child, no right child. And in the tree we had in question 53, we have 4 leaf nodes. Now we have an algorithm presented in this question, which seems to be able to find how many leaf nodes are there in a given tree. So it takes a tree as an input and checks if the tree is empty, because if we are looking at the empty node, that's not a leaf node, so we return 0. And otherwise, we have two recursive calls trying to find the leaf nodes, the number of leaf nodes in the left subtree, the number of leaf nodes in the right subtree. And the task is fix the issue in the algorithm, so clearly it means that this algorithm may not work for some cases. And I'll give you maybe 2 minutes just to think about why it may not work. You may try to draw a small tree and apply this algorithm to see what might have gone wrong. And also we try to fix the issue. So how do we slightly modify this algorithm and make sure that it's working? Then we're going to talk about it together. We got a comment from the chat window, which we probably should go through first. If T has only one child node, then there will be a null pointer error. So let's consider if the node T has only one child node. Let's suppose that T.left is a child node, and then T.right is an empty node. So we only have the left child for the current node T. In this case, T is obviously not an empty node, so we go into this else branch. Then we're going to have return leaf count T.left. Well, T.left is an existing node, and plus leaf count t dot right. As we know, t has no right child, so t dot right will be null. So when we have this leaf count null, I think we're going to have leaf count null. So if t is null, yes, return 0. So I think we're not going to get an error, because if t dot right or t dot left is a null pointer, it's a empty node, then leaf count a empty node will give us a 0. I hope that makes sense. So we shouldn't need to worry too much about this null pointer error. So what's actually the problem in this program, in this algorithm? Let's try with a really straightforward, simple example. If we have just one single node A, which is the root node of the tree, having no left or right child node, easier if I just call it T. Leaf count on node T. T is not empty. Then we go into this else branch, which will return leaf count T dot left, which is empty, plus leaf count T dot right, which is another empty. And as we just mentioned, leaf count function applied on an empty node will give us 0. So we're going to get 0 plus 0. But clearly in this case, the root node itself is a leaf node because it has no left child, no right child. And in this case, actually, if you try with an arbitrary tree, for example, I add a left child node A into this tree, I think we're still going to get a 0. So leaf count on node T, it will give us leaf count left, which is leaf count A, plus leaf count on an empty node, which will give us 0. And leaf count on node A, since A is non-empty, we're going to return leaf count on A's left child and leaf count on A's right child. So that's leaf count empty plus leaf count empty, giving us 0 plus 0 equals to 0. But clearly, node A is a leaf node. So I think the problem here is that it will always return 0 because it will always try to calculate or find the number of leaf nodes in the current node's left subtree and right subtree. So the missed case is that if the current node is already a leaf node, we want to add 1, because the current node is a leaf node. But the actual behavior is we try to find the number of leaf nodes in both left and right subtrees, which will give us 0 plus 0. So I think what we can do to fix this is that maybe we can add another if statement. So the first if statement here, we're checking if the current node is an empty node. If it's empty node, return 0. I think it makes perfect sense. Now, otherwise, if the current node is not empty node, I think we have 2 more scenarios. If the current node exists, it could be a leaf node itself, or it may have left or right or both children nodes. Now, if the current node is leaf node, which we can test by this statement. So T is not empty, and then we check if T's left child is empty and T's right child is empty. In this case, the current node T must be a root node. Must be a leaf node. So we can return 1, indicating the current node is a leaf node. And otherwise, we are going to return the number of leaf nodes in its left child, in its left subtree, and also the number of leaf nodes in its right subtree. I think this could fix the issue. So we're considering 3 different scenarios of a node as input. If the node is empty, then clearly return 0. If the node is a leaf node, then return 1 because we just found a leaf node. If the current node is not a leaf node, then it must have at least one of the left or right child node. So we try to find the number of leaf nodes in the left subtree, the number of leaf nodes in the right subtree, and then add these two values together. Now with this modification, I think it's possible. Well, this is a working algorithm for finding the number of leaf nodes. So this is one way of fixing the issue. And another way of fixing the issue, I will just use a different color. If we look at this recursive function called leaf count t.left, leaf count t.right, this value could be 0, it could be 1, it could be 2, 3, 4. So it will not be a negative value. If it's a positive value, for example, if these two values adding up together giving us 1 or 2 or 3 or 4, it means that the current node is not a leaf node because we have at least one of the left or right subtrays giving us some number of leaf nodes. If these two values are both 0, then clearly the current node is a leaf node. So what we can do here, without using another else if statement, without considering another scenario, is maybe we can just first calculate this value, leaf count left plus leaf count right. If it gives us 1 or 2 or 3 or even larger values, then we should directly return that. If it gives us a 0, then it means the current node is a leaf node, so we should return the current node. Well, we should return 1, indicating the current node we've just found one leaf node. Combining this logic together, I think what we can do is maybe we can use a maximum function comparing this value with 1. I'm not sure if this makes sense to everyone. So the idea is we're going to have the recursive calls, trying to find the number of leaf nodes in the left subtree, trying to find the leaf nodes in the right subtree, and then add up these values together. If we get 0, then the maximum function will convert that 0 to 1 because we're comparing maximum 0, 1. If this value gives us 1 or 2 or 3, then we're just going to take that value as the return value. So the green color gives us the second possibility of the modification, which I think is less modification compared to the first approach, but it requires more logical thinking. You might come up with other strategies, but you may verify it yourself. And I think this question, well, I will at least provide these two possible solutions. And if you come up with other approaches that you believe to also work, you can feel free to share. But otherwise, I think these two are the most straightforward approaches that I can come up with. Now let's move on to the next task. Question 57. So far today we've been talking about